obviously, let's just define the general terms of the horizon. It's where the Earth's surface and the sky appear to meet. Now, one thing that actually there was sound here, but
sure enough, as the boat
you're not going to be able to hear this sound. Can you hear that?
Yeah, we can hear that. That's good.
Oh,
sure can.
Oh, are you going to get will you get a copyright strike? It says it's only like 5 seconds
don't worry about
from
that. No worries there. If you want, we can turn
clip.
it down if you don't want us to hear it. Your call.
No, I just worried. Don't want you to get a copyright strike.
No worries there. It's fair use, and if not, then it's not the end of the world.
Okay, right. Hold on a second. I've got to go back, I think.
Sure enough, as the boat reaches the horizon, the stripes begin to disappear, one by one.
Cool. All I wanted to set with that was that, because I've had people pick that when I've used stuff like this, they've said, well, that's not the horizon. So see where the water ends, the land begins. They say that's not the horizon, because technically the horizon is where the sky meets the ground. But I'm just using this to show that even here on Nat Geo, they're calling this the horizon. So it's just kind of like a little disclaimer. Now, when we see a horizon, we know nothing about it. So, like when you're looking at it, you can say, how far away is this? And also, how does the distance to that horizon affect objects in the distance? Now, what am I saying what the horizon is? So the horizon is purely an optical effect. It has nothing to do with the curvature of the Earth. The distance we see on any given day has a direct causal relationship to the distance to the horizon. When the horizon is close, objects at a set distance are blocked or hidden at a much greater rate. And when the horizon is further away, objects at a set distance can now become fully visible. You guys can jump in anytime, ask questions. It doesn't have to be just me rambling. I'd almost prefer if you do jump in and ask questions.
I love this one. The horizon being apparent, right? If you ask a glober, they had to do this really weird dance of amalgamation of this. It's this physical optical thing that sometimes coexists, like particle wave duality, depending on how you're looking at it, right? Oh, I dog.
One of the early things that I remember coming into the conversation, asking about the horizon and where exactly is the curvature, is like I was always told, well, it's behind the horizon that you do see. What you do see is a function of that curvature, and it's like, what?
The ridiculous gymnastics. It's optical, right? Right there in the definition as you started, where it appears to meet, right? Done. They're like, no, but it's physical sometimes.
Yeah, sometimes, apparently.
Also,
well, you look at it in two different ways. So in one sense, it is physical. So if you were to get a boat and I was looking in my camera and I said, okay, you just keep going, and we're on the phone. And then I said, okay, stop. That's where my horizon is as you get further away. Technically, that's a physical spot. But if we waited half an hour, I might have to say, oh, shit, come closer or move further away, because now the horizon's moved for me. So now that what was a physical location has now changed, and now I have to tell you to move to a different location, which is why it's called apparent. Any questions on that? You guys follow that?
Eloquently explained.
Yeah, we'll see.
Okay, cool. All right, so then, I'm going to go into this part here a little bit later. So this is, I pinched this one from Witsit, where, the horizon rising with the observer. Okay, now, and this is one thing, I'm going to go into this a little bit later, but this is one thing that I want to sort of put forward, because even I keep saying it as well, the horizon rises to eye level. I think the better way for us to say it is the horizon rises with the observer. So that way we don't have this, it's perfectly at eye level argument with people, because the horizon does rise as you go up higher. That I will make evident as we go along. Now, just a quick thing on inferior mirages. So here you'll see that what happens with the inferior mirage always brings the horizon much closer to you than what is determined by a geometric horizon. And I think the geometric horizon is probably more just worked out as some form of average. I don't really know how else to explain what it is, because, you know, like at the end of the day, even a broken clock is right twice a day. There's always going to be a point where the horizon will be at a section where you could go, oh, that's where the globe says it should be. But to me, in my findings, it's very rare that we ever get a horizon that's right on what, or a predicted level of what the geometric horizon would be. I reckon I would probably get that about anywhere from 1 to 5% of the time. And then probably, you know, most of the time I personally get inferior mirages, depending on the time of the year or the time of the day you go out. And then on obviously many occasions I can have it where the horizon is way too far, and then anywhere in between. All right, so here's just, there's no sound on this one. So here we have a video of Wide Awakes, the last part of the sun going down. In the top corner you have Phuket Word, and in the bottom one is one of mine. These are all going over a flat plane. We know that the top one is actually flat because that's on a dam. So we see the person disappearing over a flat surface. The boat that I filmed is also doing the exact same thing, and the sun in this instance is doing the same thing. They're all disappearing at a relatively uniform rate. Well, I mean, that will change depending on the position of like how strong that inferior mirage is. It will kind of change. But as you can see, they're all doing the same thing. Okay, so they're gone now. There's no difference in any of that. And remember, like I said, jump in any time. Now, here's another one. Now, this is what I postulate what's actually going on here. So you can see here I've just got a representation of each square representing, say, a mile, because I know that this horizon here is approximately 4 miles away. Right? Now, as... thought they got rid of the sound on that one. But yeah, so as it goes on and the inferior mirage starts to disappear, right, the horizon is actually moving further away from us now. Now, as it moves further and further away, you see more and more of the land. Now, what's actually going on here is, because the horizon is getting further away. Oh, yeah, I forgot I did that. I had to screen record that just before. Now, because the horizon is getting further away, it's more of the horizon's actually getting closer to that land. All right, so if I go up here, and maybe I can pause it over here. Sorry, guys. All right, let's pause it there. Ah, damn it. Okay, pause it there. So the horizon's actually become closer to this land now, and that's why we see more of it. Okay, the horizon has moved closer. It's gone further away from me, moving closer and closer to the land. And that's why we see more land now, because the horizon is closer to the land, right? I mean, that makes sense, right? You guys picking up on that?
So you're saying it's optics based?
It's
And not
optics
physical.
based, not physical. So, and this is where we have the complete optics of it, and that the horizon is a refractive effect. Because when we look here, I mean, even though we've got a heavy inferior mirage, this is really giving us an idea of what's going on with the horizon in general, right? So here we have a horizon that's 4 miles away, and we have probably close to about 80 to 90 feet of this hidden. Whoops, where are we going there? Go back one. All right. And then when we get further up here, yes, sorry guys. Sorry, as you can see, I'm not the best at this. Okay, so we we had the other one, the other screen, or the other screenshot that we were just showing, where we had 80 to 90 feet blocked. And now in this one here, I would say that the horizon, because that bit of land there, or we can see this little white section just here, this is 15 miles away. the little bit of land just in front of this here is about 14.3 miles away. So I would actually say that the horizon here is 14.3 miles away and possibly even further. It's just that this is all diffraction. So this is, I'll show in a little bit later in another part where I do mirror flashes, and it's all like this, right? So it's basically diffracted. It's showing Rayleigh's criterion, you know, where everything becomes of one. The reason we don't see the actual shore is because at the end of the day, this is 14 miles away. So that's, what's 14 times 5,000? So what's that, 70,000 feet away? Maybe 75,000 feet away. And we're missing probably about 10 feet. So over 75,000 feet, the angle towards seeing that 10 feet is just so minute. It's all blended into one. And that's why we don't see the bottom here. So when I do the mirror flash, you'll see that you can see the mirror flashing, but you can't see the person. You can't see anything else there. Actually, I don't think I had the little video for it, but I can get the video. I think I just did a screenshot. But you can't see the person. You just see the mirror flash, right? And that's, to me, that's just a perfect explanation or demonstration of Rayleigh's criterion, where we're not actually being able to resolve the image. We're only seeing the light because it's powerful and it's able to break through that. Now, wrong way. Now, I don't really want to put you through. Let me turn this down. Don't want to put you through Wolfie's voice. Now, many people have come to me lately and going, "Hey, we never said that an inferior mirage had anything to do with the curvature of the Earth," which all of us who've been in this for a long time know that's just complete horse crap, because it's something that has been used time and time again. And this is a video from Wolfie. Let's go further up here. It's one of his Bathurst Lighthouse videos. Why is this not adjusting? Or did I change it? Okay. Not sure what's going on there. Sorry about that. That was completely...
I'm looking out across towards a number of ships beyond the horizon, and I can own...
All right, let's go over here. Why won't it let me do that? Okay. That was a waste of time. Sorry about that. That's meant to be something else. It's meant to show his observation.
looking out across towards...
This one will do anyway. So this is one of Wolfie's observations here. Now, as you can see, there's an inferior mirage there. And he turns and says, this isn't the one that was just on, but this is a different one. He basically claims this to show the curvature of the Earth perfectly. The lighthouse is touching the water. And this is 12.3 miles away. And he is 6 feet above sea level. Right? So if we go back to here, on this day here, I'm 20 feet above sea level, but this is 14 miles away. And when we skip through here, as I showed, the houses there are... Oh, God damn it. Why is this not working? I would have thought this would skip through. And there I go, ruining everything again. Sorry about that. So here we have the houses. Everything gets shown. We see everything now. So when we go into, here's one here, all we've got to do is wait or come back a different day, and I guarantee you we would see it all the way down to the shore at this. So I'm actually thinking in about a month or so, I might go spend a week in Perth, because I reckon the conditions will be pretty good. During September, the conditions are generally pretty good. I reckon I'll be able to see all the way to the ground. Now, oh, here we go. Here's another one. Sorry, I forgot to put this one in here.
Earth curve's just going to move out of the way for you.
The Earth curve is just going to decide to fade away and become non-existent. So here's another one. And this one's much clearer, so you can see the inferior mirage a lot better. And once again, he claims that this is all Earth curve. He claims that it perfectly shows Earth curve. He doesn't mention the inferior mirage at all. Right. So now this is an animation that Mick West does, where he's showing, objects in the distance rising and falling due to refraction. But what this doesn't account for is it's not accounting for the horizon actually changing positions. He's just accounting that these things are moving up and down, where that's not actually what's going on. What's happening is the horizon is actually moving. Now, there are times when we get real full-on refractive effects like what we're seeing some of those Skunk Bay ones, where you're starting to get superior mirages and all that kind of thing. And you will kind of see this rising and lowering of the ocean. But that's during sort of like quite heavy refractive days. That's on days when we're getting superior mirages, that's quite heavy refraction there, or a different form of refraction. And then you can have all kinds of weird, funky things happen. Right, so here we have this one from Zanuck. Now, I can't use a pointer or whatever, but the one on the left, he's turned around and he said, okay, so why, his idea here is he's going, why is the one at the back lower and the one at the front higher? And then on this day, on the one on the right, now they're both at the same level, right? Now, how did he explain this again? Forget how he explains it properly. It's gone from my brain right at this moment. But he's going like, how is this differing, right? Now, I might be able to explain it better here. So when we look at these two screenshots here, whenever anything is on the horizon, it is going to appear higher visually than everything beyond the horizon or everything in front of the horizon. Okay, so you see on the screenshot on the left, we have the buoy is right on the horizon, and behind the horizon we have Brighton Jetty, and all we can see is the tower. We can't see the jetty at all. Now, when you look at the one on the right, now the horizon has moved further away from me, closer to the jetty. So now the jetty is closer to being on the horizon. So now the jetty is higher and the buoy is lower, because the buoy is now in front of the horizon and the jetty is now on the horizon. Just as here, on the right-hand side, the horizon has now moved further away. So the distant oil rig has now appeared to rise up, which is not what has happened at all. All that's happened is the horizon has extended. And now that the horizon is extended to the point where it's at or beyond the oil rig, now the far oil rig is at the highest point visually, which is the horizon, and the one in front of it is now lower because it's in front of the horizon. The one on the left-hand side, the front oil rig is on the horizon, or just slightly beyond, I would say. So it is higher in our vision, and the one further away, because the horizon has now moved closer, it is now dropped below our vision. Do you have any questions on that? Did that all make sense to everyone? Did I lose you?
You're good.
Yeah, good.
Oh, okay.
Yeah, it makes sense.
Yeah.
Anyone? No questions? Anyone? I think all clear.
Okay. All right. I just because that's actually quite a big one, because this is one where people are sort of wondering, like, why is everything dropping below the horizon? Now, I'm sort of going to get into this a little bit later on how I started coming up with this. But that screenshot on the left and this one on the right are the two things that actually got me really started on it. Like I already knew the horizon was moving, but these two things here is what actually sort of really made me start thinking about what was actually going on and why things are disappearing beyond the horizon. Because like angular resolution and all that works to a point, but I think that works much better when we have a really extended horizon. Then we get our Rayleigh's criterion, we get the angular resolution, we get the diffraction, all those things really come in. So I haven't got it in here, but I did film a ship the other day, maybe 2 weeks ago now, and that went out to 31 miles away. And all that happened was it just ended up getting so small and opaque that it just disappeared. But I could tell that I could still see the hull of the ship, because when the hull of the ship was black and a little line, and right at the very end of it, I could still see the hull of the ship. You could still see like a little black line. Okay, so I knew that I was still seeing the entire ship. It just disappeared. So where are we going on from here? Okay, so now I'm going into actually demonstrating the horizon moving and changing positions. Okay, hold it, sorry. Before we go into that, here is distortion. Some people like to say, when we see images or videos where we see further and it's distorted, people like to claim, well, it's distortion, that's why you're seeing further. Well, here is distortion and we are seeing less, right? We're getting this inferior mirage. Sorry?
Oh, that's beautiful. I love this this clip right here.
Yeah, thank you. And then in this next one here, now we're seeing further, we have the same distortion. Right, so distortion doesn't mean we're going to see further. We just need to clear that up. All right, so this is hopefully that can become clear for everyone. Now we're moving back into the horizon actually changing distance. All right, so here we see the buoy, horizon well beyond it. That's the same day. I just had to join two things together so we could tell that that was the area where the buoy and the jetty are. Again, this is one that I was using just before. That's the one from before as well. You see the buoy. Obviously, there's an inferior mirage there. Buoy is on the horizon. Now, actually, this is another thing that I'll clear up again as well. Now, let's say I'll go back here just quickly. Sorry. Oh, yep, that one there. So this line right here, this is the horizon. Whatever we visually see is the horizon. So I had good old E. Golder on Twitter. We've all dealt with him on our lovely X space. He came into my thing one time. Let's go back. He came in and he was like, drew a line here and said, "Oh, there's your horizon there, right, where the fold line is here." Well, that's not the horizon at all. Okay, we can clear that up a little bit later when I go through different parts. But this is not the horizon in any way, shape, or form. Normally, I can see well below here, and in fact, this is the area where I did a mirror flash from, where my friend had the mirror down on the sand, and we got the mirror flash. And all I wanted to do with that's not necessarily proving flat Earth in a sense. It's proving that I can see all the way to the shore on most days. But this, where the line is here, this is the horizon. This is what we see visually as the horizon. Okay, let's just skip through this again now. So I might just escape this so then I can go on.
So they try to argue that the mirror line is their horizon?
Yeah, I mean, and even flat earthers have said that. I've seen it before. It was something that many people said a long time ago. If we actually go up here, if I go back to this one here, sorry, and we just so how long have we got, guys?
As long as you need.
As you need, brother.
Oh, okay. Well, so if we look here in this top one, even Phuket word here, mentions actual horizon. See that? Apparent horizon, actual
Right.
horizon.
Right.
See? So even Flat Earth has got this kind of wrong for a long time. Now, if you were to talk to someone like the Plain Truth Travis, I'm your Copernicus on Discord.
Right. Ether
He wouldn't, the Ether band guy, yeah, he would not agree with that being the actual horizon there either. I think this is just something that we were still figuring out. At one stage, it was still being figured out. Let me get back over to around about here now. Okay, so I've actually got.
I just
sorry,
want to
go on.
add real quick that if they're going to invoke that the mirror line is the horizon, if anybody invokes that, then those pictures of the ship that's floating, they couldn't say that the horizon's down at the bottom. Then I mean, they would have to just acknowledge that the water itself is reflecting the sky, giving the impression that the boat is floating. Right.
Yeah, for sure. Now, but that's such an interesting observation, that one, right? Because now I don't think anyone will ever describe that properly.
Right. We're
like
all
that,
kind of like learning how to describe things properly. That's kind of the challenge, right?
Yeah, that observation there, where the boat actually is floating, that kind of it's such a hard one to explain, right? Because so the image that we're looking at right now, we know that all of the top image is being mirrored in here or mirrored in here, right? So we know that that's mirrored. But when you look at that observation of the boat floating, only the sky is being mirrored. So I say that the ocean is mimicking the sky, because when you look at the boat, there's no mirrored image of the boat. And that's what's bizarre about it. Do you get what I'm saying?
Right. Well,
So when
if I remember correctly, I don't believe the picture itself, the original picture, was zoomed in like your photos are. I think it was a panned out photo where they cropped out where that took place. Now, if they had zoomed in, perhaps they could have caught the shimmering of the waves, etc., and seen all the distortions. But because it was cropped out of a larger photo, and it wasn't zoomed in, it didn't hold the same what do you call it, like all the definition and all the resolution.
Yeah,
So
for
it
sure.
looked like this flat color.
Yeah. Now, sort of what I'm saying though is, so let's just extend this red line across here, and we get all the mirroring underneath. But when you look here, now imagine that this was all sky, and this jetty was here, and then this was the same color as the sky. This would look like it's floating, but not mirrored. Do you get what I'm saying? So when you're looking at when you're looking at that ship, you see the ship. You don't see any mirroring, but you see the color of the sky here. And that's why I think no one is ever going to be able to explain that one properly. It's a really bizarre observation. So yeah, I don't know, man. That's a really weird one. I've really tried to think about that, but that's why I just say it's like it's just mimicking the color of the. How does that move?
It's
just
so I
mimicking
feel like we're challenging like people's understanding of how to even interpret most of these pictures, man. Because like the what's it called, the the one they show at 24/7 all the time, the black swan, right?
Yeah.
They show these comparison photos where in one picture you can see the black swan, and of course there's a little squiggly line, so it looks like there's a little distortion. Fine, whatever. We can see beyond the oil rigs. But then in the other photo, it shows this massive wave that is right in front of and obstructing half of one of the oil rigs. And I tell them, I just try to remind them, like you have to think about what is happening. You can't just look at a picture. You need to be able to think about what's taking place. Like the camera's 1 foot off of the water, looking 10 miles. Okay. Any amount of like a millimeter of a wave or just like a swell will consume the bottom half of the screen, if not the whole screen. Okay, so you can take a screenshot at any point you want to get the impression, the manipulation of what you think is happening. And if you're not thinking about it and you're not trying to interpret it and falsify it, then you're going to miss it and you're going to be running around like a chicken with your head cut off.
Yeah, definitely. Now, when we look at this on this day here, as you can see, if I was to just move that up slightly, see how I do say large swell. So there was quite a large swell on this. Now that is obviously also a part of the reason of why it's brought the horizon closer to us and why it's hiding more than normal, because this is not, I've seen, this has probably only been maybe 7 or 8, maybe 10 times I've had this much blocked. Right, it's not normal, and it is also during high tide. So a combination of high tide, waves, and maybe a tiny inferior mirage here, and we've got this whole thing blocked out. Right, so that's kind of like what waves can do. And I wasn't going to show some of the other stuff further up on here because I completely screwed up the labeling. I thought that some of the houses that I was looking at were in a completely different location, so I have literally hundreds of screenshots that I've taken from my videos of that area and then completely mislabeled it, which is really annoying because it was so much time and effort to do that. That was ages ago, and then it was only about a couple of months ago that I figured out that, oh shit, I've been labeling the wrong place.
Mm-hmm.
So very frustrating.
I also wonder how much of is it the actual swell of the water, and how much of it is just like a heat wave magnifying the foreground,
Yeah, well, it's part of it, it's refraction in general. So heat wave, magnification, it's all kind of due to refraction really at the end of the day. Now, actually, Heath Carmody just released a pretty good video the other day. I'm not sure if any of you guys watched it. He's actually been making his own little program as he goes along. And
Did you repeat that again? Who is it?
Heath Carmody. Do you know him?
Carmody. Yeah, if you could post a link at some point, that'd be great.
Yeah, he does. He does amazing observations. He's been doing it for years.
Oh,
just
great.
incredible stuff. Where, a lot of my observations would be a hell of a lot better, but unfortunately I'm on a jetty, and that jetty is always moving, and then there's always people walking on it. So I've always got to whenever I do any videos, I have to spend so long just taking the shake out of the videos. Whereas people like Heath and I'm Your Copernicus, The Plain Truth, they're like sitting on land, so there's no shaking from people walking, which is really nice for them and unfortunate for me, but that's just how it is. If I want to see this from this angle, I have to be on the jetty.
Mm-hmm.
So whenever I show something and you see this angle, there is only one place I can be, and that's on a jetty. So as we move through, you'll see, so there's the buoy right on the horizon again. Maybe I'll just go into a larger screen for a moment so I can just skip through. We see the horizon moving. So now on this one here, due to the inferior mirage, the horizon is closer than 3.6 miles away, because that buoy I've been and had a much better look. It's actually 3.6 miles away from me. So horizon's now just slightly in front of the buoy, well in front of the buoy, in front of the buoy. Or when I say in front, like beyond it. Now it's closer to me. It's much closer to me now. So, and here's one that I Am Your Copernicus will like, Travis from The Plain Truth. So if we look at, let me escape here. So if we look at from here to here,
Mm-hmm.
right, where the mirroring starts. Now, science and everyone within optics, your PhDs, everyone forever has told us that this is a vertical image, right? Well, this isn't a vertical image because it's starting at about 3 miles away, and this here is 8 miles away. So between this point and this point, you have 5 miles. So what Travis explains is that this is more like a shadow. So imagine, like, say, a tree here and the sun belting down here, but then the shadow would be coming out this way, right? And there would be a shadow of the tree going like this. Well, that's what's happening here. This is a 5 mile, whoops, wait. This is a 5 mile reflection.
Right. Well, it's all those. Well, notice how like smooth the water is. This must have been a very calm day.
It was a calm day.
And what I'm imagining is that all of the peaks of the water have joined together and created a physical surface to reflect the image off of.
Yeah, definitely. Now, this is the weird thing, is that for ages I was like thinking, well, only to me, seeing these images shows this is a flat surface, and I know that it's flat all the way across because we can look
The way
at
it's reflecting.
Yeah, the way it's reflecting.
Yeah.
Yeah. Now, Slice Barcane released a video going only a curved surface would show these mirages, which is just ridiculous because Sky Free shows it over a flat surface day in, day out. So it's just an asinine thing to say. Yeah, I forget where I was leading with that. But yeah, so this is definitely over a flat surface. I've done mirror, my mirror flashes are from just beyond there. So my mirror flash, the buoy, like this is Brighton Jetty here. And if we keep moving, this is to my right, further over that way, then that's where the mirror flash was done. So the buoy, this is the jetty's 8 miles away, and the mirror flash that I did was from an area that's 9.6 miles away. And then I also did a mirror flash from another point, which is 12.6 miles away. And that mirror flash was done from 1 foot off the ground.
Now, I just want to ask you real quick, when you're drawing this red line, is this overall out of a cropped, zoomed in photo, or is this the whole image and you've just highlighted the the mirror line? Like, well, I guess what I'm asking is the camera level? Is it completely level? Were you leveling out the camera before taking the photo?
The level, no, this is from a video.
Okay.
If I go, yeah,
because my point is, I'm trying to figure out, like, you're saying that the horizon rises with the observer, and
yes.
I'm just trying to see if there's any of that characteristic, like throughout your evidence, But if we're not looking, level out, then don't worry about it.
That's all right. Now, if we look here, so all of these are taken. So for the longest time, I didn't do this. I've got about 50 days where I've actually started doing this now, where everything else was all just video. I never took photos. And then one day I was watching one of Travis's interviews that he did with a PhD in optics. And that guy mentioned to him, it's fantastic that you have all these photos that are of the same focal length. And I went, oh, shit, why haven't I been doing that? So I started doing it. All right. So all of these here are the same focal length.
Right. Just keep like a standard of observation, right?
Yep. This is like, look at this refraction. This isn't me not focusing this. This is literally the image
this is
of the
all
day.
You get.
That's what you get. Okay?
Maybe I missed it. What camera are you using? What setup?
A P1000.
P1. Okay, I've got a P900.
Yeah.
Yeah. If this is the best you can get with the 1000, man, that's I hope I can do just as good.
Yeah, well, currently now I actually just bought 3 more P1000s.
Oh,
so
okay. Well, if you don't need the old one, just let me know.
Yeah. I've actually I've got six P1000s now.
That's awesome.
Because
wow.
I've got 4 areas that I want to film. So whenever I go out, I'll go out sometimes for like 2 or 3 hours, and I'm trying to always get like an entire, many hours period of the difference and how it looks over that entire period. So I can then put it in fast forward later and show
You know, something
total
I've
difference.
often asked the globe side is, is the object you're looking at and you're measuring, is it the actual size it is predicted to be at that distance? They calculate their angular size when they're looking at the stars and whatnot, but when they're making all these refractive claims, they're willing to just accept that it's obstructed from the bottom up as their evidence without accounting for, well, should we even be able to see a building that takes up that many pixels at that distance? Or is there some other effect happening, blowing it out or shrinking it or dropping it down? I don't see that at all, but I see you here counting pixels. I appreciate that.
Yeah, so here, maybe so I can point. I'll have to get out of here because it never allows me to do that.
Well,
I'll just blow.
can I just
blow
real
this up a
quick?
little bit.
Maybe
Yeah.
it's kind of what you're maybe about to get into, but just to kind of expound on what Riggs was just saying there, right? Like, if you're going off the pixel size thing, like there's a particular function where as something is moving away from you, the amount of pixels it is going to take up on your screen is going to decrease, and that function is going to describe exactly the that value that you get of the number of pixels. And something above the ground, above the quote unquote horizon, something above sea level or ground level, is going to have its own value of pixels. And then the ground itself, in the sea level, the water, the ground, the waves, they also have their own value. And so what people seem to not be able to, they kind of tend to overlook, is that there's a play between these two values that's occurring, so that as something goes down to such a minute pixel size, and it's already at the horizon, it's at the merging point. When you're at that tiny point, you're at the merging point there. So you have something that is so far away and it's such tiny pixel, it's already going to be such a tiny amount of pixels. And if that wave comes up just a tiny bit, or there's a tiny hump in the ground there, that ratio of pixels that closer thing gets is going to take up space at that compression point, aka the horizon. So I'm not sure if that helps at all, or if maybe I'm making it more confusing, but like that ratio, I think, and the interplay between what you see at ground level and what you see quote unquote above ground level or at eye level or above the horizon, the interplay of those two things and the way that that pixel, that resolution grows and shrinks as things get closer and further, that's kind of a complex relationship that I think people don't give enough due to, maybe.
Yeah, definitely, and that's what I'm showing here. So yeah, completely agree with everything you just said. So from the buoy here to this point here, this is 5.5 miles away. This is 3.6 miles away. So in between these two lines here is 2 miles.
Yeah, this 2 miles within a couple inches on a picture, right?
Yes, like it's nothing. Yeah. Right? Now from here to here, this is 5.5 miles away. This is 8 miles away. So now we have 3.5 miles in this tiny little bit here. Now this is 8 miles away, and I just drew this line out even longer, and you can see how you can just, I'll blow it up even more. See that tiny little bit of blue there? That's almost 1.5 miles.
Is that like 2 millimeters?
It's God. It would all depend on how you looked at the video. If I did the picture like that, it's like a tenth of a millimeter or something.
So, and in those miles, right? You're compressing all of the reflections, all of the distortions, and it's essentially creating a line in itself. And things beyond that line can be obstructed. So you're not going to see the shells on the shore, the rocks at the water. It's there's too little information. This is the problem with distance.
Yeah, for sure. So when we look at a day like this, there is a slight inferior mirage here. There's 8 pixels to the horizon. I think there was a slight inferior. No, maybe there's not a slight inferior mirage on that day as well. But now we've got 9 pixels. Right, that's a slight inferior mirage there. Obviously, a heavier inferior mirage. The inferior mirage is right on the buoy, so
0
the horizon
pixels.
is at 3.6 miles away. So all of these are done at full focal, completely all the way out. This is day to day.
Is that buoy anchored? Does it just sort of drift back and forth? Or is it stuck in place?
It's pretty stuck in place. I mean, if it does move, it's probably moving like 10 or 20 meters. Like it wouldn't be moving much. Like
I imagine it like moving with maybe it's on a chain or something that's anchored.
Yeah, it would. Yeah, that's right. It would be on a chain or some form of anchoring, and that would obviously have to allow and give it room for tide and waves and so forth. So, I don't know, let's just throwing some numbers out, let's say if the ocean there is 40 feet deep, they've probably given the chain 70 feet or something. So it probably moves slightly forward, slightly back. Nothing to really nothing to say would really change anything I'm saying.
Mm-hmm.
So I hadn't finished doing all of these and putting all of these in, but you get this idea and you see the way that it's moving. I'll close. I'll strengthen this one now. If I go here, I did some of this, which you might. So there's a comparison of this day. I'll blow it up a little bit bigger. So we see that image on the left. So this is the same day. And this is actually, I mean, if you're looking, it is although it's a hazy day, it's a defined clear horizon, right? Now, the image on the left, I've had a mirror flash from the ground there. That's the point that's 12.6 miles away. But on this day here, this nice, pretty crisp horizon is at about 16 meters above sea level. Well, not above sea level, above where I have filmed it on many, many, many different occasions. All right. And you can see here on the left the way that the image looks towards the jetty and how it correlates. So when we're seeing that and the horizon closer to that buoy, we're also then seeing a much different image over there on the left. Now, the geometric horizon should be at about 8 meters, and this is at about 16 or 17 meters, this horizon right now in this image. So it's not matching the globe. It's not matching what they're saying. Okay, oh, there we go. There's another day of it. And this one here, I did do this. So if I click on there, I think I did this. This is from the same day.
From the same 16 meters.
No, this is, sorry, different day from the other one, but these two images are from the same day, same location. So this house here,
you overlaid them. I see.
Yeah, I've just overlaid. So this would have been the afternoon, or like a couple of hours later, and that was a couple of hours earlier. So when we see someone like Wolfie who shows an image of a lighthouse blocked by an inferior mirage and says, "Show me the land," oh, there you go. There's the land. And this is where I got a mirror flash from, right here.
Right.
Now, what we can see here this little point right here. See this little slight discoloration? That's a little
Right.
concrete surface just there. That concrete surface goes down to, obviously, to the sea level, to the ocean. Goes all the way down. Now you can't see technically that because there will be rocks here, like rocks that are about 1 to 2 foot above sea level, but you can't see them. But you couldn't see them on the day I got the mirror flash there either. This is basically diffraction, right? We can't see any of that. But if I was to do a mirror flash on this day, I guarantee you we'd get a mirror flash.
So the mirror flash would present itself as some kind of white blinking, some kind of blurry blink.
Yes,
Right.
like
So
this.
the information's too blown out and diffuse. It doesn't mean it's not there. It just means that you're not getting any resolution, so it looks like a horizon line.
Yeah. I know on this day, because we've done 2 mirror flashes from this point here. This is a short video that I did on my X profile. Now you can see here, this is all distorted.
Right.
There's lots of diffraction going on here. I couldn't see my friend, and we had about a 3-foot swell, and that's why the mirror flash is from 1 meter.
Well, then
We had
what
about a
is
1 meter swell.
when you show this to people, like what do they say? What do they say to combat this? Because you're essentially shooting through what they would consider to be this actual horizon.
Yeah, well, I don't know if you're on Twitter. Have you joined any of the Twitter spaces? Have you seen a guy named Swala?
No, I don't.
Yeah.
I'm not the big Twitter guy.
Okay, yeah,
someone.
the last
He
in the
shows up on
background.
Friday nights.
Yeah, we've all dealt with him every now and then. Now he went and did a he went onto AutoCAD and did something on this when I did this, and he's like, "Oh, look, see, it almost matches," and he couldn't get it to match on AutoCAD with what he was doing, and I'm like, he was like in his video, he goes, "It's close," and I'm like, "Yeah, close isn't right, bro. you didn't get it right. Why are you acting like you had a victory there?"
Mm-hmm.
But either way, all I was mainly doing with this more than anything is proving that when I see this, I'm actually seeing the shore. And I've seen this kind of image
Right.
more than 100 times. Now, this is a different day, much clearer day. This is that same house right there. So we could pretty much guarantee that if he was down here with the mirror, I may have even seen him on this day.
Right.
See the same house? Whoop, I gotta do that. See the same house here? That's the same house.
I'm not sure what exactly would prove at this point, but would you happen to have any other kind of like shapes of mirrors, like a zigzag or an S or a spiral or just something that's not like just a flat sheet, so that we could get some kind of just some kind of design to see what shows up on the other side of the blurring, you know?
Yeah, it doesn't. This mirror here actually is. It's not massively wavy, but it's got a small wave in it. I think all you end up getting with a mirror flash is just the flash, no matter what.
Yeah, it's just too much
Yeah,
diffusion.
it's just way too much. And so here's another crazy inferior mirage day. This you can see the buoy up here. This horizon here, the inferior mirage has probably brought this horizon to, God, maybe 2.5 miles away from me. All right, because between that point there and that point there, that's 8 miles, and we know that it gets even tighter and tighter over distance. So as it's closer to me, this is probably at least 1 mile, at least. And then this is that same area where I did the changing the levels on. This is that same area. All right, and then this is technically what the horizon looked that day. it just looks kind of normal. I mean, obviously there's a lot of haze, but there's the horizon. It just looks like a normal horizon, right? When you're looking at that, you're not going to realize that all this is going on. It just looks normal. Yeah. Okay.
Yeah, those
Yeah.
are wildly different photos.
Wildly. So there shouldn't be anything here. So here's a comparison as well.
Yeah.
So this is the kind of that's what a inferior mirage can do. It can hide the entire area. You know, we go from being able to see all of that to seeing like that little house right there is this house here.
Huh.
You know, and this point right here is 13 meters above sea level. This wall here is about 3 to 4 meters tall. So we're talking, this is more like about 20 meters.
Oh,
Up to
wow.
here
That's
is
a
about,
massive wall. 3 to 4 meters
this house
tall.
is huge.
Yeah.
This is a massive house. These
That's
people
a
are.
backyard wall. Yeah. Keep everything
Oh, yeah.
out.
But I hadn't been down there, and then when I did go down there one day, I didn't realize this shed here is actually a part of their property. This is a massive property.
Wow.
This is probably like a $3 or $4 million property. Beautiful. Really, really lovely place. And so this up here is probably at about 26 meters. So over 70 feet, maybe closer to 80 feet. And then we've got mirror flashes from here. And then on other days, we can't even see up to here. Let's go back to this other one now.
Do you take any pictures of the sunset, or as it's crossing the horizon line, or the haze, or anything like that? Just curious.
Yes, yeah, I do. I have technically multiple videos that I've actually made. I just haven't posted them.
Right. Well, I just figured it would be within your wheelhouse because I get so many people posting, what they would consider to be the horizon line when they're looking when the sun is closer to the horizon, right? And then as it passes through the haze, it'll reveal the real horizon line and then a reflective layer. And then they suddenly have to move it a few inches up in the picture. And that just seems to be very related to your work here.
Yeah, one thing that I find interesting with the sunset that not many people, I'm trying to load something in here. Come on, hurry up. This is an interesting one to get, some of you guys who are clearly more on the ball, I would say probably smarter than myself, is this.
Did you just use the colloquial metaphor on the ball to mean smarter in a presentation on the horizon in a room full of flat earthers?
Yes. Yes, I did.
Okay.
Now, when we look at this, look at this going through the refractive layers.
Yeah.
Right? As it goes through the refractive layers, it gets lower. This is our azimuthal grid of vision.
When it flattens out.
Look at it. Look at it going through the layers as it breaks through the different layers of the atmosphere. Or I prefer to call it the atmohemisphere, because it is a hemisphere above us. So you see, as it's going through, it goes through them and it gets lower and lower as it gets through. This happens the whole time. It's just to a lesser degree. So I don't know if there's a way someone like you, Shane, you're onto this way more than what I am, whether or not you can sort of implement that and sort of have a look and think about that and how how it's actually going through the different layers of the atmosphere, and as it does is when it sinks. It gets lower and lower. This is probably a better one. Not quite as heavy refraction or like so much distortion on this day. You can see it going through all these different layers. And as it's moving further away, perspectively it's getting further. So it's perceptively getting lower and also going through these refractive layers. But yeah, I don't know, maybe if someone like yourself, Shane, if you can think about that and run with that.
The atmospheric deck of opacity has a gradient not induced by gravity, right? But
Yeah, definitely. All right,
You
so
gotta be-
let me. Sorry, go. Yeah.
You got to be careful showing people those videos. I mean, they're amazing, but you know, I've seen so many people
I already
take
sold them.
screenshots and say
Okay, yeah, just what you're saying.
that the sun is in the clouds.
Oh,
Yeah, yeah.
Riggs, that's how I started, man. Okay, that's what brought me here. I don't disparage those people.
Yeah, well, I mean, optically it looks like it's in the clouds, but we all know it's not.
I don't know.
Hey, sorry, guys, give me 2 seconds or like 30 seconds to grab some water.
Yeah,
Absolutely,
Well,
no
I would say now we all know it's not Riggs, if that's better.
There's something appears to be in the cloud that looks sunny.
The fact that it can appear to be so, though, is evidence to our position. Like
If only we had time for a commercial break.
No, I
Yep,
killed all
okay.
the penguins. Okay.
We's back. All right, so part of what started bringing me to what's going on with why things are disappearing beyond the horizon was because I started using these 2 images on X. First of all, I just used this one and I started going to all of the trolls. I'd post this and go, "Oh, what's going on here? What's happened?" And then I would post an image with this of from Google Earth of the actual whole jetty itself because I didn't want to post another picture of it just yet. And I'd say, "What's going on here?" And then they would sort of start to get a little bit shady, and many of them didn't want to answer me. So I thought, hold on, I'll start with this image. And I'm like, "What's going on here?" Clearly, almost 100% of the time, 99% of the time, the only person who didn't fall for it was Fight the Flat Earth. So kudos to him. But 99% of the time, they went, clearly that's over the curve, you idiot. So then I was like, okay, what's happening here? If you're going to say that's over the curve because you can't see the bottom of the ship, why can't we see the jetty? And many of them fell for the bait. And they said, well, it's because it's over the curve, idiot. And I'm like, well, what about now? What about now?
Dun dun dun.
Because dun dun dun. Because this is only 8 miles away, and according to their geometric horizon, or according to their math, there should only be about 4 feet missing. But there's over 20 feet missing here, or approximately 20 feet missing.
And,
This here is
and
at
an
about
hour
25
later,
feet.
it could be completely different.
Exactly.
Right.
So then you're sitting there going, okay, so what's going on now? And after all this arguing and debating and so forth of this, it then dawned on me one day that this is pretty much in the middle. It's 3.5 miles away from me. This is 8 miles away from me. So it's almost smack bang in the middle. I'm at 20 feet observer height. 20 feet's missing.
Mm-hmm.
This is in the middle. And then I started thinking like, okay, hold on, wait a second. So if I'm a 6-foot observer and my horizon's 3 miles away, what's the hidden amount at 6 miles away? Well, it's 6 feet. Because I'm 6 foot up and then you got 6 feet hidden. So
How
then
tall
I
is the
started.
buoy?
The buoy's approximately 5 feet tall.
Right. Okay.
Yeah, it's not massive. But yeah, so I started thinking, well, this is almost a 1-to-1 ratio of I'm at 20 foot. This is in the middle, and we've got 20 foot hidden. And then I went, okay, well, how does it work? Like, so if we're 12 miles away from a set height, obviously then at 24 miles away, you have the exact same amount of curvature for each person. So you split it in the middle, each person's got 12 miles, right? Now, this is where we start to go into the horizon rises with the observer. When we look at an image like this, which boat is closest, which boat is the furthest, and how do we know that? All right. So let's just, let's do the quick question. Which boat's closer, guys? Can someone join in with me?
I'd say the middle one's closer.
This one?
It's really hard to say.
Maybe?
Let's not worry about it. These two. Let's just say these two, right?
Okay.
Yeah.
I was
Yeah.
going back and forth between those.
Yeah, sorry. Yeah. This one here was actually.
Those two
And
look
which
pretty
one's the
similar.
third?
Yeah, okay,
Got 'em.
gotcha.
See, I knew it was a
Dude
trick
thought he was
question.
giving a little alley-oop, and he gave him brick.
Yeah, we thought we were
That's
getting
the one.
tricked. Like that's a trick question. Yeah, that's
We don't
funny.
want to.
Yeah. Sorry, guys. Didn't mean to throw that little curveball.
You're
Ah, you gotta keep it fresh.
on the front. Yeah. And then which one's furthest?
The one in the background.
Obviously, the one in the background, right? It's obvious if we draw lines on them. That's where that one is. This one is at this line. This one is at this line, and this one is at this line.
Right.
So what happens as we're looking out over the horizon? Now I'm at 20 feet. I'm in my usual spot. I'm on the jetty. I'm at 20 foot observer height. Obviously, this is 0 feet. All this water is at 0 feet. All of these are at 0 feet. But this is visually lower than this. It's slightly visually lower than this one. It's visually lower than this one, and it's visually lower than this one.
Yes.
The horizon is appearing to rise in our vision. All right?
Point.
Okay. Now, when we see an image like this, everything from high goes down, everything from low goes up. Everything that's above in the sky drops to the horizon. Everything from it's actually on the ground or on the surface or on the water will rise.
Well, that's not fair. I thought that everything in the world does that: buildings, skies, see the planes, but just not the sun. I thought no, everything's different.
Yes. Yeah, man. Everything is different. So here I was out on a day, and I think this was one of the same days. My camera is at this high.
Do you ever
Right.
put calculations into like obviously the land is meeting the sky and the sky is meeting land like that, but do you have any that going compressing in from side to side, kind of giving us a pigeonhole or a tunnel vision?
Compressing side to side stuff?
Yeah,
No, I
As-
haven't actually.
up and down. The sky meets the land, compressing down that way for a.
Oh, right. Where it's coming down there. No, I haven't really sort of done anything like that. But yeah, so here we have that same thing. Which boat's closer? Which one's further? We can see this little boat here is larger. This little one here is smaller. This one's lower than this one. But what I'm doing here is the railing is about 1.5 feet lower than my camera. The camera is leveled out so that my little green horizon line was put right on the horizon, and the camera's about 1.5 feet above the railing. We've got about 1.5 feet above this person here, right, above the railing. Now, on this day, right, where are we going? Is that going to go? I think it is. I'll play. Now, from here, I then dropped the camera. And what do you know? Holy shit. It seems like the horizon just dropped.
That's crazy. I saw the Earth come right up at it, though.
It's amazing, isn't it?
Dude, I think the Earth shrank.
It did shrink. But yeah, like, I mean, this is one where I just don't even get how people argue this point. Because, I mean, all that happens is going from one spot to the other is all that's happening in a level change is an extension of the horizon. And you're just seeing more. And then when you see more, it just appears to rise. It's all just visual. We all know that. It's not actually rising. It's still well below you. And then this is the other thing, is that technically this horizon is actually 20 feet below me. So if you were to do a theodolite, clearly the horizon is 20 feet below you, so there should be a gap between a perfectly level theodolite and the horizon. It should be there. But this is why I say what we should be saying is that the horizon rises with you and lowers with you. All right? And so this is apparent here where we see something like this. This is how we see everything. We'll go here, right? So I've just done all these same things and put them at ships that are the same size. And so now we have the ships that are the exact same size. And we do the same questions. Which ship is at the back? Which ship is at the front? We know there's two easy ways to tell it. We've got this one is visually larger and it's visually lower. That one's visually smaller and it's visually higher. Now, what could we ascertain from this picture? Approximately where is the observer in this picture? Now, I will escape from here so I can go here. We see the horizon is here. All of these ships are the same ship, so we could possibly assume that the person on the ship in front is possibly on the same ship. So they're observing from around about this high on their ship. Right, so what do we got here? Let's just say it's 60 feet, 70 feet. The observer is approximately 70 feet high here. Does that, we can, that kind of makes sense to everyone?
That checks out for me.
Yes.
All right.
Dude, that was a whole bunch of work for like a 40-second video presentation. I know how much time that took, you know?
Oh, man. Yeah.
That was awesome. Like that little segment that was excellent.
Oh, thank you, bro. Me and my crappy computer skills. I'm getting there eventually. Slowly starting to work out how to use Keynote. So yeah. So in reality, we know that they're all the same size. So now we're just going to have a look at a few different Navy ship formations, and they all follow the same pattern. All right. Navy ships demonstrate that the horizon rises with the observer. So we see that ship there on the right. Sorry, you going to say something?
No, I was going to say that's. I didn't realize that was unmuted there, but that's
Oh,
probably.
there you
Caught some unfiltered reverence off the cuff.
Yeah, so we've got that ship that's really close to the horizon, which I had to zoom in on, is visually higher than these ships. This is a point of where I'm going to get to something a bit later. If we were on the other side of the horizon, that's how we would see it. Now, we know that all these ships, sorry, hold it, where am I going here? These ships are visually well below the horizon, possibly not even seen from the other side. That's a point for the other part. So here we have the visual height of the horizon above the ships. Kind of shows us how high the observer is, right? So let's just say that these ships themselves are 30 meters tall. We know that the observer is well above these ships, well above them, because we have a ship that is close to us that's about 30 to maybe 40 meters tall, and it's still well below us. So who knows? Maybe the observer here is like 200 or 300 feet high. I don't think they're on a ship. I think they're probably on a helicopter. All right. Now, when we look at something like this, and we have the horizon at the red line at the top, we sit there and say that the observer here is possibly even like 1,000 feet high to 2,000 feet. And we still have this, everything as it gets closer to the horizon rises. All right. We see these ships as we get closer to the horizon, they rise. We see the horizon is above this level of the ships because the observer is probably on another ship on one of the decks, and that deck is probably at about 60 or 70 feet, approximately. I'm just having a random guess. All right. But we can tell that because of how high the horizon is in comparison to the ships. And that was me just mucking around. The same thing. Now here we have a whole bunch of ships. We know which one's closer to us. All right. We know which ones are further away. I shouldn't need to draw in all the lines by now, but clearly any glober watching this is going to be like, it doesn't work that way.
Or rather, it doesn't. It works that way right up until the edge, where it suddenly works a different way.
Yeah. Well, my argument is it's actually working identically the opposite. And I'll go over that shortly. So there's a horizon that's pretty pixelated. Sorry about that one, but we see the same thing again. We see it here. The observer's clearly at more like a few hundred feet high, right? The horizon is rising with the observer. This observer is lower, but still, probably 30, 40 feet. This observer is close up to the clouds, so, a few thousand feet. We know that ship down there on the left-hand side is a aircraft carrier, so what's that, a good 150 feet tall? We see all the ships obeying the exact same rules, and they are moving up into they are getting progressively higher in our vision. Right, so now we know that the observer is lower again, and we see the ships going up in our vision. Right, now here we know that the observer clearly must only be, 10 or 20 feet up. Here the observer is quite low as well, and here the observer is even lower again, maybe only like 10 feet again. We see the horizon just in the middle of those ships. We see the horizon just in the middle here. These two ships are the same. Who knows how far? Maybe this is a half a kilometre further away than this one. Clearly this one's larger. This one looks smaller, but they are the same ship. We're all on par with the horizon rising. Everyone's sort of like getting that?
Yeah.
It appears to do so.
Because it's something that we've all said it for so long. We all know it, but it just gets denied so much. And I don't know about you guys, but it's a pretty frustrating thing, especially for someone like myself who's dealing with the horizon all the time, and people sort of going on about it.
Well, maybe you're talking to the wrong people.
I am talking to the wrong people. That's for sure.
I think the fallacy comes in when, first of all, they say that objects are below the horizon, and then also that the horizon is below the center line of a camera. And, I imagine if I'm rising off of a surface and there's more distortion at the bottom, that distortion would collect and eventually obstruct a small area in the middle. Then you would have the line just below it. So it makes sense to me. For some reason, they just kind of ignore it or go sweep past it.
Yeah, I would say we get some of the Rayleigh's criterion and angular resolution affecting. There's definitely an effect to that, but then also things do 100% disappear. So we kind of got to have the explanation as well, because then that's what I was saying. Like with my ship that went 31 miles away, that was 100% angular resolution, diffraction, Rayleigh's criterion. That's why that one eventually disappeared, and it disappeared exactly as the Globers would say should happen on a flat Earth. It was a dead flat ocean that day. It went miles away. The horizon, like, it was kind of like hazy. And then eventually it got smaller and smaller and smaller and eventually disappeared. It did exactly what they say it should do. Right? But here comes my little animations on what I think's going on. So we've got two people here. Now, they are both, I missed it, right? I forgot to put it in, I missed a part. Where is it? Anyway, it doesn't matter. So what I've done is I've basically said that this is 12.5 miles. This is 12.5 miles, or 12.25 miles, right? So the horizon on the geometric is meant to be 100. Oh, sorry. There's meant to be 100 foot of hidden, or it should be when you're 100 feet high, 100 foot observer height. Sorry, I had to recollect my thoughts. The horizon is 12.25 miles away on the geometric. So if we put them both at the exact same distance, this is what they're going to see. So this is how they see it.
This is awesome, dude.
Yeah, nice
I was
job.
like, he's looking the other way. He's gonna miss it. Nope, dude took care of it.
As details
Yeah.
matter.
So this is what they're seeing, right? Now, when he sees this ship go beyond, he sees this, or she's seeing this. He sees this. All right? Now, obviously, when it hits the horizon, they both see that. When it starts, because it's this, let's say the ship is 100 foot high, she can't even see the ship because it's just out of range. But now as it starts to move, he sees it get higher in his vision. All right? She sees it start to get higher in her vision until they both see it on the horizon. Now that it's reached the horizon and it comes towards her, she sees it drop. He also sees it drop.
Dude, I love the way you did that. That is an excellent way to portray it. Wait, did the dude fall over in the last slide?
Yeah, I did way more than
perpendicular.
It's like, he's trying to find the curve. He's right on the edge, dude. His face is on the ground, trying to look real close.
He's like, "Am I standing on it? Am I the horizon?
Am I the curve?"
Yeah, I actually did way more than that. Where did I put it? No, I won't do it. I won't show you. Yeah, but yeah. So when we go back and I look and we go to this one over here, and we go here, this is the same thing. If you were the person on that jetty there, wouldn't see me over on my jetty on this day, possibly. We have the horizon in the middle. If there was a boat, or let's just say there was a boat that's only, say, 6 feet high, well, let's just say that boat's 20 feet high because we have 20 feet missing. As that boat would go away from me, I would have seen it get higher and higher and higher until it hit the horizon. Person over here would have slowly seen it getting higher and higher and higher until it hit the horizon. Now they'll see it drop in their vision as it gets closer to them, and I will see it start to disappear. But it's a product of the position of the horizon, because on this day, I would have watched that same ship go all the way to the shore. So I think the drop rate is probably correct, but it's only correct on after something hits the horizon. And that position of the horizon, as we have seen, can be drastically different depending on the conditions of the day. So,
Man, that is a wobbly looking Earth curve. It's all over that place today. Earth curve everywhere.
it's crazy, bro. Absolutely crazy. So when we look at something like this, right? So this is 15 miles away from me. And we see all of this land here. I'll use this one here. Go over here. So this is 15 miles away. We see all of the land. In fact, sorry. Which one would be better? All right. So imagine here on this day here, this horizon is just over 3 miles away. And I know that because I have all the footage from the buoy on the same day, and the horizon was right where the buoy is. So it's 3 to 3.5 miles away. Now, if we had a ship move away from me on this day, by the time it gets to here, the land here, even the biggest ship would be virtually 100% gone. Now, if that same ship 3 hours later, because there was 3 hours in between these two, just so you can see that again, from there to there is 3 hours difference. That same ship would go all the way to the shore and I would see the entire thing. But let's say that this horizon is at 15 miles away. Now that that ship would start going beyond this, it would start to disappear at, I suspect, the predicted rate. But it's not going over a curve. It's now just doing perspectively what all of these do. Prospectively, they look well below because this guy's at, let's say, 100 feet. Now, let me explain something else to you here, so you kind of get that a little bit more. Now, to get an observation, right? Where are we going here? Right. To get an observation where you have, damn it, what did I do? I ruined it. Maybe if I do that, it ruins it even more. There we go. To get an observation, oh, Jesus. Sorry, guys. All right, we'll use this one.
Okay, take your time. No worries.
Yeah, no worries. I'll get there eventually. To get an observation like this, to have, say, 90 feet missing, and probably even the Halleck Cove one would be better, sorry. To get an observation like this with, say, 17 meters missing, I would probably have to be at 50 feet, 60 feet high. Oh, no, sorry, I'd have to be lower. Sorry, I'd have to be lower. I'd have to be at more like, maybe 7 or 8 feet at this distance to get this much missing. But I'm at 20 feet. Right now, you guys have probably seen, and I didn't have that ready, but you would have seen on my X profile one where that land that is, so this land here, I have this land here looking exactly like this from a 15 centimeter camera height. Now, at a 15 centimeter camera height, there should be 150 feet hidden at this distance. Right? I shouldn't see that. But yeah, I can mimic that from a 15 centimeter camera height. So what this basically shows is that you can mimic like as if you have traveled higher and lower by going up in elevation or down in elevation with just the horizon moving position. Does that make sense to you guys? Did I make that clear, or was that not clear?
I think you've been super clear the whole time.
Super
Okay.
clear.
All right. I just need to check. So when we look at this and we go, all of these are below the horizon. I'll go to a more zoomed out one, even this, right? So all of this is well below the horizon. We have an observer that's, let's just say, 1,000 feet high, just for shits and giggles. This is 1,000 feet below him. If you had the exact same distance from here, an observer on the other side of this horizon at the same height, they wouldn't see this because it would be 1,000 feet below them. It would be 1,000 feet below this horizon on the opposite side of the horizon. So what we're getting is a production, like is a product of the horizon that once everything hits the horizon, it drops. It disappears in the same way that we get this dropping as you go higher. It's really hard because I know this in my brain. It's hard for me to get it out, so that's why I keep asking, is it making sense? Is it being explained clearly?
Yeah.
Right. So, and maybe someone like yourself, Shane, could model this out. And I've actually discovered an AI program called Claude 3.5. Have you guys seen that one?
Yep.
Yeah. So I reckon that if I get the prompts right, I might be able to get that to do an actual model for me. So I'm sort of going to start looking into that.
There's definitely a knack to whispering it to go against its heavily propagandized grain to lie to your face. But if you can work against that, yeah, it's very helpful.
Thanks, man. Yeah. So, this is the part that I sort of want to get across, and then get you guys to actually really think about it. Because I know you say that it makes sense, but I just sort of need to know that it is fully making sense. Can someone steel man it to me? Is that possible?
Yeah, so your horizon essentially encompasses everything in this screen, and then beyond the horizon, you'll get the same sort of angle of trajectory on the other side. Is that your working theory?
Yeah, pretty much. That's not too bad. And so it's a product of the horizon itself, and being high above the horizon in these kind of shots shows that. And then also my other images where you can mimic how high you are by how much you see, then kind of shows that it's a product of the horizon itself, because all that's happening is the higher you go, the horizon gets extended. That's all that's happening, is the horizon's getting more and more extended,
Your angle
further and further away from you.
Yeah. How about putting it like the angle of it isn't increasing, but the distance is compressing more land into that same angle the higher you go.
Yes. Okay. Yeah, what Shane said.
Probably more what he said than what I said. But have you challenged this idea with like perhaps like infrared?
No, I've got to get an infrared, and I think all that will do is just extend the horizon further.
Okay. So it'll change. It doesn't change your angle, but it changes how much fits within.
Yes.
Yeah. It'll then, so instead of even maybe from the same observer height, instead of maybe the horizon being, let's just say 7 miles, the infrared may make that horizon now 9 miles. So you'll just get more information squeezed into that last little point.
I imagine, okay, so in infrared, I would imagine that everything in this view right here might be slightly pushed down to make room for the more information going towards the red line.
Yes. Yeah. Yeah, I agree with that.
Okay.
Because that's the product of the way the horizon works, is that, like if this person was to drop their level, next thing you know, say this boat here would be on the horizon. And if they drop down even further, maybe this boat becomes on the horizon. They drop even further, this boat, and they drop down even further. Now you might even see this boat on the horizon. It's purely just a matter of changing levels.
Mm-hmm.
Yeah, man. The other observation that I think I'm trying to make now is that you have to have like when you're if the horizon if it was perfectly in the middle at the median and you had equal distance on top and equal distance below, then it would decrease equally at the same rate. Does that make sense? Like they'd both like the top and the bottom would appear to disappear. You wouldn't have like bottom up obstruction usually, right?
Yeah.
But we never observe it equally. You're always so much closer to the ground than you are to the sky in observations like this, then the angles become unequal. Thus, they cannot decrease equally. They do so disproportionately, right? Because as the top increases, the bottom must decrease to maintain proportionality. So like just based on the face of it, if you're starting off very close to the horizon, percentage wise, proportionately from from the sky, then of course the only way an object could disappear, according to Rayleigh's criterion, is bottom up. Is everyone? What do you guys
Yeah.
think?
Oh, 100%, man. Completely agree with that. I mean, let's just take, when you look at this, I mean, the bottom is touching the ocean. The top is not. There would probably be even parts of the very, very bottom of this that just with your eye you might not be able to resolve. Now, when it gets all the way to the horizon, clearly this is the part, the bottom is the part that's going to be unresolvable, not the top.
Yep. Couldn't be any other way.
No, exactly. I mean, no, it's something where I
Couldn't
guess
be any
every
other
single one of
way.
us has had.
Yo, that's such a key point too, right? Like it, globe or flat, like this is just rules of optics, like it, and I feel like that also gets glossed over by globers quite a bit.
And
Yeah,
ignored. And like because they know diffraction is real, right, and quantifiable in Rayleigh's, and the rate at which those angles subtend, like that's diffraction, right? The angles at which you can become unresolvable, and they don't ever account for that, even though it's mathematically feasible, describable, occurrent in every observation. They just go, oh, you know what it is? Earth curve. What? Never before substantiated thing that you guys pray to and need to hold. What? No, of course it's not that. How is it not the finite, mathematically, empirically verified thing that we know is there and happens every day based on every optic? How are you gonna implant curvature for that? But that's definitely how it's born, right? It's like, oh, actually, it's not dependent, absolutely predictable and consistent diffraction. It's unpredictable nonsense wobble fraction that is exactly however we need it to make it not look flat. Okay. I mean, that angle thing though is here. I think Indio did he did a pretty much a graph paper on it, right? You like graphed it out, took the angular resolution limit, put it in, drew like two dots of the bottom of a frame of view and object, and said, okay, these are the 2 points that become unresolvable. And then as those dots like move away from you, or as they move, or as you move away from it, the angle to those dots doesn't change, but the distance that you can't resolve becomes vastly more, becomes way more increased the further you get, just because the distance, that much more distance, is being crammed into that compressed more space. Like,
yes, agree.
If I
Now,
may say something as well too, it's not necessarily to do with optics, but just basic geometry. So as someone who's studied a lot of art, music and art has been kind of my thing for a very long time. Just basic geometric shape. If I'm standing at a shoreline, I should be at the tallest point of the horizon. Therefore, I look left, I don't see it curving down. I look right, I don't see it curving down. The horizon line in front of me shouldn't even be at eye level. It should be below my eye level. because of the fact that I would be at the highest point of that ball at that point. Now, if they wanted to claim that there was an ocean wave, like say if I was somewhere, you know, that they claim the equator has a 20-foot wall of water or whatever, if that be the case, it it would still, in that case, it would be a mountain of water, but it would still be curving to the left and to the right. And so just visually, when you draw things like this, and you can do it on a piece of graph paper, like, or from, you know, we've all played first shooter games, like the horizon level is always flat when you're painting. I mean, we have that Bob Ross clip of him saying, you always paint the horizon flat. Like that's, we know this to be true. And the fact that we go up higher and it continually rises, and it's not perfect, but it does rise. The fact that it rises at all and doesn't continue to drop tells you right there that it can't be what they say it is. And I don't really care if people want to invoke refraction and all this other stuff. Geometrically, it does not work that way. Or like when you look at it artistically, like from a geometric shape kind of thing. Is there any like, would anyone say otherwise on that? Because to me, if I'm on the beach looking out, I should be at the tallest point of the horizon. Like I should be at the top of the ball, right? Regardless of where I am.
I mean, I just think that it's all optics, dude. I think that we can prove it, dude. I think
Yeah.
just because we see it on the horizontal plane all the time doesn't mean we can't see it on the vertical plane. Like if you look in the chat, there's this picture of these super tall buildings, say like 150 floors, and if you stand like underneath it and look up, you can replicate the exact same effect that we're seeing on the horizon, which is angular compression at a rate, except now the top box is much closer, so the angle is vertically compressed that way. So you see the same effect in reverse. Like that should solidify it to everyone that, hey, that's what we're seeing on the reverse on the horizontal level.
Mm-hmm. Yeah, well put. Now, someone like Sly has pointed out that he seems to think that this border is in the exact position that it should be for the globe. Nah, if you say so. But what we know is that because this is higher technically, right, than this. This is at 138 meters. This is at about 30 meters, these houses. This is 31 miles away. This is 15 miles away. And when we look over here, what do we know about everything that's higher? It drops. Now we just have a horizon and we have water in the way. If there was no water here and all we saw was land, we would still see the same thing. It wouldn't change. But it's not, it's all just optics. It's just that this is higher, no different than when we have something like street poles, street lights, and we see them get lower in the distance. They're joined, they're connected to the ground. They still get lower and lower and lower. This is connected to the ground. It's higher, but it's so far away now, it has dropped in our vision. And now it's dropped to a point where it appears to be at the same level as this. All it's doing is this. It's just dropping lower.
That's crazy. I think that's the best example. Like you see these planes, because this is the same argument they use for Polaris and the stars to say, oh, look, the Earth's curve. Like, what? Yeah, see that plane?
Yeah.
What? What? It's like, yeah, if I take the sign and I guess where that plane is, I can get a height. And if someone else takes the sign and guess where that plane is, they get a different height. The Polaris can't be like, that's not, you guys are just using apparent positions as if they're real. And that's retarded. And that's the other side of the globe group doing what they're doing on the ground, right?
Yeah, exactly. They're looking, going, oh, yeah, see this plane here? That's right above you. And now this plane all the way over here? Well, now we've gone over a curve and we've gone, 1,000 miles away or whatever it be, and that's why we see it lower. But no, it's just prospectively it's going to get lower.
Well, that's how much Earth curve is there, actually, I think is what you meant to say.
Yeah, sorry, man. Sorry. It's all Earth curve.
It's funny that you're like, he said this is how it should be on the globe, and he's kind of right. because they just take real life observations that are way too far in the globe, apply a coefficient of refraction between whatever 0 and 3, which would adjust it wildly right up until the point they make it appear that it's actually flat, right? And then however much refraction they need to inflict upon that retroactively, that's what the coefficient ends up being. It's just sad that it doesn't work the other way, as Kemba always points out. They can't say, hey, based on these conditions, here's how much wobbly Earth curve is going to be. They can only say, hey, based on how far you saw it past that curve, here's how much refraction we needed to bring it right back in line with our prediction post-diction, rather.
Yeah, exactly. And what gets me about the way that they go about that as well, let me see if I think I've got it on this one here. I think so. Maybe I don't. No, of course not. Yeah, like the way that they draw lines from everything, and they go, well, see, this one is 10 meters high, and this one is, that's the one I just opened. What are I doing? That was an accident. This one is 20 meters high, and this one all the way over here is 120 meters high, and they draw this orthographic side-on view, and they go, well, see, that's 10 meters, that's 20 meters, and that's 130 meters, so that one should always be seen higher than these ones by X amount, forgetting the fact that we see like this. We see everything rise. We see like this. Technically, all of these ships are the same. They're all this size, or they're all this size, however you want to look at it. They're all this size, but because they're further away, they get smaller. And obviously, when they get even further, they start to get our visual dropping below the horizon due to the way I feel and have explained through this. All right, so we're getting all these things, but they're kind of just a bit mixed up on how they've got globes in their eyes.
I want to be mixed up. It's actually very calculated how they selectively employ aspects of each one of those things whenever it best suits the globe and doesn't disprove the globe. I would say it's pretty concentrated, calculated, and concerted effort to willy-nilly nick and pick between all those things, depending on what suits the globe. That's how they've been doing it, right?
Yeah, for sure. Now, here's just some other little comparisons. Same day.
I think you needed another set of lines on your ships where you show the different ship, same size ship, but as it goes out, before you were showing lines on the bottom of the ship, of each ship, and how it's rising.
This one?
Yeah. But if you had lines at the top of the ships, you would see that they're going down. Even though the bottom of the ship is coming up, the tops of the ships are going down as they go away from you.
Yeah, you can see higher, lower, lower.
The question is, at which rate is it doing so? And is the top doing so faster or slower than the bottom?
Yeah, I mean, I know Phuket Word, I've got one of his where he describes it as it's a 23.2 degrees this way and 23.4 degrees and 23.4 degrees, which is, like our the angle to the sun. Now, this perspective angle is what he says.
Yeah. Yeah, I just meant more like because you're almost at the ocean floor level, then the angle at which things disappear would definitely be from the bottom up, because there's no way those angles could compress equally, where they wouldn't, the top and the bottom would disappear completely, or would compress the other way because it's such a difference in angles going to the skybox, as it were, than to the ground box, right? Because your observer height is starting so much closer to ground level than the bottom angle is, the way in which that sometimes the light in the back of your eye, that the angle at the bottom angle will have to decrease faster than the top proportionally to maintain, proportionality essentially.
Yeah, for sure. And it's obvious, which part of this is going to hit the horizon first, that bit or that bit. I mean, we don't necessarily agree with what rockets do in space, but this isn't rocket science. Like, it's about as basic as it gets.
This is where they hit
I mean,
all the Earth curve. This is how they got everyone.
yeah, definitely. But yeah, maybe that's probably technically about it. But yeah, because it was kind of like this part here is one of the main bits that I sort of needed to also get through the fact that the horizon moves and the way that people see.
If I had just made that little cartoon, I would have made a 2-hour presentation around it too.
Yeah. I made more. I actually did it so that this little dude, because he flies over and she kicks him in the face and then kicks him again.
Those guys are so funny. That's pretty awesome. They animated that. Just fun with stills, man. You just make it a GIF and it's over.
Yeah. Let me see. Where is it? Copy untitled.
You're much neater. All my shit's named untitled and then numeral sequence quintillion or whatever.
I think I put it here. Oh, did I? No, damn. Where did I put it? Because I've been working on a thing and I've started naming all these characters. Corey
Nice.
for
Nice.
Surfy for Surfy, Sly Dog, and just some random dude.
Dude, these are all Globers. All right,
Yeah.
let's all right. What we should do though is put their faces as the circular profile of random Twitter globe trolls. So instead of just like a white circle, do like slice, whatever his fucking name is, just as the face, and then still draw the eyes and the mouth. What do you think?
Good idea. Yeah, it's not bad.
And then do one for each of them or whatever.
Yeah.
I mean, to be fair, that one of them gave us a video that was like, I ended up using as my favorite globe evidence, and he took the time to put all of our names in his globe proof. He was like, Shane's over here, and Witset's over here, and they see the sun, and the angle's wrong because I'm retarded. Whatever. So maybe we should do the same courtesy. I got a real kick out of that.
Yeah, no, fair enough. And it's just like where I was doing one where, like, they seem to think that we see the world like this, side on. You have all these things.
Dude, this is what orthographic life should look like. A fucking cartoon.
Yeah. No, that's a good point. That's a good graphic.
That's great.
But really, this is how we see the world. But the scale.
Oh, God.
But the scale. It's so much smaller.
You like an animator and a cartoonist on the side for fun and just happen to do flat Earth presentations as a bonus, or what?
I figured out how to do some stuff on Keynote, so I was like, I'm going to muck around.
Mucking around is pretty funny. Look, he's so angry.
Yeah, so I'm going to do a video of this whole sort of thing where I incorporate the actual footage and all this sort of stuff, and my just some random guy is going to eventually turn into a flat earther because
he's already character evolution.
Yeah, because he's just kind of like
it's character development. In this
he's got an arc, dude.
He keeps looking at.
Going to learn. All the rest of them aren't going to learn lessons. They're going to remain Globers forever.
Yeah. So like where I go here, the object which gets smaller in the distance, and he's like, of course, everybody knows that. And then the next one, it's like, these guys don't know it. These guys have no idea.
It was big, but now it's small.
Yeah.
Man, I was going to say, plain reality, all your presentation, I've seen it before on a different channel. It's always mind-blowing, encouraging. I like your attitude, even though there's a lot of anti-flat earthers out there. You're just maintaining with the truth. And I think these comical ones are good. Like, they're good for you to cope with the insanity out there. So keep it up, brother.
Yeah, no worries. Thanks, Ron. Thanks.
They're good
thanks
for me to cope too. So yeah, keep it up.
Yeah. Now that you guys are all laughing about it, I need to find the other one because in my thing that's Sly Dog and that's Surfy.
While you're looking for it, I'll tell you the horizon really understanding what we see and how we see optically really is what woke me up to flat Earth. Like seeing the big white fluffy clouds directly above me and me understanding how high they actually are. And when I look off into the distance and I see them going and smashing into the horizon, I know that's not Earth curve. Just like I know the train tracks don't actually converge, even though they look like they are. I know that the sky and the ground run parallel, and just because it looks like they smash into the ground, it's not because we live on a ball. And it just clicked, and I was like, wow, we were lied to. This is amazing.
Well, I think this was a great presentation, dude. I like how you were like, how long do you guys got? And we were like, bring it. How long? How long can you go for? Let's see.
Just go for it. Oh man, what happened to that?
Yeah, the backstory is that Alan's first presentation was 9 hours or something. No, wait, 7, 6, 4. It was like 4 hours.
Nice little 4-hour piece.
That he whipped out in the middle of a debate.
Here we go. We'll see if this is the one.
Yeah, dude, I like how she starts fall, looks confused, gets up, sees it going away, gets sad, falls over again. Dude, now he looks back. Wait, where's he going? What the hell?
Oh no.
Dude, she
There's
there's a love story.
Whoa!
He drop kicks him in the face.
Yeah. There's a backstory to that because
somebody really get murdered.
Yeah. No, Sly came to Surf Perzel's rescue to his to her oh god, what's the word for it? Yeah, he came to rescue her one day.
Knighting like a bitch.
Damsel in
What you
distress.
meant to say, yeah, right?
Yeah, he was white knighting hardcore. Okay, here's the bit where Sly did this on my observation. Well, this one's this high, this one's this high, and this one's this high. Why do we see it? Blah blah blah. So I did this because I posted this to Surf. I'm like, oh, why did you send me something that was in an inferior mirage? This is one of Soundly's. And I'm like, why did you send me something that's in an inferior mirage? And she goes, you don't see an inferior mirage in the video I showed. And I'm like, oh, really? Yeah, you do. There it is. There it is. You just don't know what you're talking about. And then Sly came to White Knight for maybe I don't have that one here. Yeah, Sly came and White Knighted for her, and then made basically one of these little things, and was like, oh, he thinks that the inferior mirage. Basically, he came up and he said that I think that this tiny little inferior mirage here can hide 28 stories. And I'm like, well, no, that tiny little inferior mirage isn't hiding 28 stories. Sorry, my phone's ringing. That tiny little mirage isn't hiding 28 stories. The fact that it brings the horizon closer to you is what's hiding those 28 stories. Right? But yeah, partly it is. It also partly is that. Yeah, that is hiding it.
Dude,
because
I'm trying to imagine a Glober coming to the rescue of some lady on Twitter. Let me protect you from the truth from these flat earthers. Like, what?
Did the big bad flat earther say you were wrong? Yeah. Because it's like, I mean, have a look at that. Look at this inferior mirage. Is, really hiding all of that. That's what the inferior mirage is, really hiding all of that. So when he says, can the inferior mirage hide all of that? I'm like, yeah, sure, of course it can. This is only 14 miles away. Of course it can hide it. Look here there's the Buddha on this side. The inferior mirage and the horizon is hiding all of that underneath there. So yeah, this little inferior mirage can hide that.
I saw some personal attack memes, and I want to give you extra credit. I too like to make memes on the fly aimed at specific globe trolls. I find it very effective.
Oh yeah. And I had that E Golder, which I then put a post about, and he got really angry when I did that post. He's like, "F you!" He just started losing his shit.
Yep, that dude got really angry because I made a video calling him the leader of my fan club because I went through his like profile and every fucking post was about me. So I did like a 30-second thing. I was like, dude, you know how like love and hate are so close? You must really love me because all you do is fucking watch all my hate posts and you repost all my things. Maybe you should just be the king of my fan club and get away with it. And then he was just so fucking angry. He snapped. I thought it was hilarious, dude.
Nice. But yeah, so he did this. Yeah. He did this here and was like, oh, the bottom part is hidden by the horizon. And I think he had another one where he went like, and he drew another line or something. So he's implying that this is the horizon. So I went and I did this. And I'm like, yeah, the fold line here. And then he laughed. He's like, oh, the fold line. I'm like, dude, that's just what they call it. Look in the scientific papers. But the fold line is not the horizon because that's where that fold line is on that day. And that's where the fold line is on that day. So clearly the fold line can't be the horizon. And he got angry because I made a post on it. I actually made a post of it.
Yep. He would get very angry. That smells of butthurt.
Oh man. And then he's what gets me with these guys is they constantly post the same thing. So like he does it and Sly does it, right? So Sly will constantly post not this one, but you know, another one kind of like this, where he's done something along these lines, right? Not this exact one. Oh, maybe it is something similar to this, right? He constantly posts this and goes, oh, he never answers this. I've answered him like 50 times. But then he'll post it again and go, oh, he never answers this. I'm like, are you fucking retarded?
That's definitely what they do. I think Rory does that a lot. He has his like one thing come into space, or just say that one thing, will instantly refute it. He'll just pretend like not to hear you, then go ask the next person and just say the same thing. And he'll do it the next time you see him, and the next time, and the next time, and it's ridiculous, dude. But conversely, if you only have like one toy, right? And if you had to be honest, it means you lose your toy. But if you had to lie, you can keep your toy forever and there's no consequences. Which one would you do?
Yeah, for sure. But it's kind of like if they said something more along the lines of, okay, yeah, you've told us what you think it is, but I disagree with you, that I would go, that's a bit more honest. But they just don't even acknowledge that you even said anything. They just go, he never answers this.
Yep.
And you're like, oh man, what the hell's wrong with you guys?
Well, and then there's like the 7 things they say no flat earther can answer that we literally answer all the time. That I myself have spent like channels and playlists dedicated solely to answering. They're like, no flat earther has an answer for the sky.
Yeah. Yeah. No flat earther can explain a sunset.
You've never even heard of a sunset. You don't even know about nighttime. Yeah. You don't even have a map, dude. we need to get a poly back. We need to get a parrot.
Yeah, I can stop sharing, or I can just, just keep these on here and you can, look at them. Doesn't matter either way.
Well, cool. Thank you so much for presenting. That was fantastic. Great. It's always good to go over this, pretty crucial to understanding optics and what we see at a long distance.
Yeah, we kind of hit optics hard, and we left the horizon completely alone over here in Aether cosmology. So I'm glad that we caught up and did this one day, all of the horizon that we haven't done.
Yeah, well, it's kind of like I think in that optics one where you sort of talk about the drop rate and that sort of thing, and I'm like, yeah, that's spot on. Everything you were saying was 100%. And that drop rate happens once something hits the horizon. But the position of the horizon changes all the time. Like, I mean, just look at this image as an example. We're seeing every single part there is to see. Like, I know for a fact I would be seeing the shore at that point, and that's 14.5 miles away. Right? So on this day, the horizon is more than 14 miles away. But you just can't 100% tell, even though you can tell better on this image. Right? But I think there's meant to be another image to go with that as well. But anyway. But yeah, so now look at this day. I mean, sure, it's an inferior mirage, but obviously we can't see the shore now because the horizon's been brought closer to us and we have an inferior mirage. So we can't see the shore now. It's so plain and obvious. This day we can see it, this day we can't. And we just get this, there we see less, even less, and it grows or shrinks depending on the day. Even this image here, so if I exit this, on this section here, this is where the horizon should be. This is at about 50 feet right here. So the horizon should be around here. Because at this point here, this one here is 16.7 miles away, this section here. And the horizon should be geometrically 66 feet. So it should be up here. But it's always...
I think I say geometrically, meaning like on a physical Earth where the horizon is caused by the geometric physical Earth curvature, here's where it has to be, and it has to stay there, right? Because that's what it is.
Exactly.
Oh, man.
Exactly. And as you would see that, when I scoot through here, apart from any time when we have the inferior miraging, to see all the way down, and especially to see that nose section, right? You can see that nose section there, nose section there, there. Can't see it there. Inferior mirage can see it there. All right, inferior mirage. Nope, and that's where I end because that's all I've got of those ones. But I could literally show 150 days worth out of 450 where you can see that nose, maybe even more, maybe 200 days, right? So it's not an uncommon thing. It's almost an everyday thing. As long as there's not an inferior mirage, you can see that.
I think it is.
And even depending on where the inferior mirage is, I can see it anyway. If the going towards the end of the inferior mirage, I can still see it. But yet, technically, on their
we've been
model,
going about 2 hours. If you want to,
yeah, man,
wrap up
end it.
soon?
Sorry, I could rave forever. No, man, wrap it up. I can. Let me get onto thingy, and I'll unshare my screen.
What do you guys?
Yeah.
What do you guys think about the angle? The same argument applying like at a tall building, right? Because if we can demonstrate it elsewhere, doesn't that like seal the deal? Instead of bickering over this one thing, like, well, it could be. We can be like, nah, it's definitely this. See how it's definitely this when you look up? Yeah, it's definitely this when you look horizontally too. Like if you're standing below a building with 120 floors and someone on the top floor is wagging a flag out it, you can't see that shit. Those vertical floors have been compressed visually into the angle because the top angle has increased way faster than the bottom. The reverse is happening. And because that happens, and that's a fact, right? Like, how can Globers be like, okay, well, it happens there, but the exact same thing doesn't happen at horizontal? Actually, what happens is a phenomenon called Earth curvature totally takes over at that exact spot, and that's all the evidence.
Yep.
Like,
the
what?
Earth curve does it, man. It's like a refraction thing. It's a distortion thing. And the way the space is curved makes the floors look like they're different heights, and
It's not that mass attracts mass. It's that the bending and warping of space-time brings mass together. So you might think that mass is bringing mass together if you didn't have an outside reference frame.
That too. Yep.
I really like the building. Just illustrates the same thing.
Right? I found this the other day and I went, oh my God. this is like, I went, well, how did I never just like, this is it. To my head, I went, duh. And now, okay, like Glober is your move, right? Where's the other example of that wonderful Earth? Like, no, never. No, we're saying it's optics. We have math to back it up. Optics. Plain Reality did an excellent job of substantiating. Look how optic it is. Look how optics it is based on. Look how it wobbles optically. Like, and then all the evidence is just it's optics based. So if it is an optical phenomenon, Earth curve is dead.
Speaking of optical phenomenon, I think I heard some testimony from Lily earlier that she was actually blind as a child, and she wasn't able to see the horizon or anything until she started drinking brushtail coffee. True, Lily?
Actually, I have a different, better testimonial. You want it?
Oh, yes.
Absolutely.
It's better than curing blindness? Yes.
Oh, yeah. So, I used to have really big feet, like size 9.5. I mean, they were like huge and with hairy toes, like a man's feet, like ugly. And then I started drinking brushtail coffee, and now they're just a beautiful size 6.5, totally feminine feet. And the other day, I went barefoot walking on the beach, and I was offered a foot modeling job. And that's the magic of brushtail. And I'm sorry to say, but that was more exciting than even getting my sight back.
Wow.
Wow.
Having aesthetically pleasing feet for other people is definitely more beneficial than being able to see for yourself.
Well,
I'm so
yeah,
glad
I want
that
to.
brushtail was able to help you.
I want to shout out Lily just to have the ability to admit that sometimes the superficial things do matter, and just having the smaller feet was a better life improvement than gaining her sight. But in any case, there is a consistent factor here from what I can tell, and that seems to be the brushtail coffee. So I don't know.
Oh, it's definitely the brushtail coffee.
Yeah,
And as
we
far as the
tested it.
blindness goes, I mean, look, even Elon could have given me eyesight back. So, I mean, the fact that brushtail did it, that's a different story. But could Elon really have made my feet look feminine again? I don't think so.
Wow. Yep. That's a great
Reversal of
point.
troll foot. That's definitely in the footnotes for the product.
And this is all alleged, and also you should not use a brushtail coffee as an eye drop. You should not do that. That's not how it's intended to be used.
Or toe fungus paste.
This is all just based on a basic consumption. Whatever that means to you.
Oh, you could use it at foot baths, though, definitely.
That's true. But yeah, for real, everybody, go to brushtail.coffee or brushtailcoffee.com if you want to order some coffee that I roast fresh. And if there's no other final thoughts or questions here, we can go ahead and wrap streams up. Thanks again,
There is
Paul. Yeah. Oh, yeah.
There is one final thing.
Mm-hmm.
Oh,
Mar, are you on?
Mm-hmm.
You there, brother? Waiting for a guitar solo.
To whom are you calling to? Oh. Someone missed their pre-dunk.
Toby's got it. All right, well, happy. So, for those of you who don't know, it's Shane's birthday today, and we're all going to sing him happy birthday. On 3, lads. 1, 2, 3.
Oh.
Happy birthday to you.
Happy
birthday
to you.
Oh, that's really good.
Happy birthday, dear Shane. Happy birthday to
You all
you.
super gay. All of you. JT's the gayest. I can hear him singing with his harmony.
That was awesome.
As you can tell, that was totally rehearsed.
Hey, we were all
I
the
will
right
always
time.
know your birthday.
Thanks everyone for listening in. Y'all take care. I'm closing my stream.